the p subscript 6. P can only contain 6 electrons. Then if you add the subscript together, they will give you 17. But the group is the last last shell of the element. Since the group last element is having 2s and 3p, and since the last 3p is not fully having the maximum capacity of 3p, is now having a capacity of 3p5. Then we add the 3s2 plus 3p5, that is 2 plus 5. Then this group fall in the group 7 of the periodic table. Then since 3 appears at the shell of the element, then 3 becomes the period of that element in periodic table. Another one is calcium. Calcium, if you follow the pattern of electronic configuration, you have 1s subscript 2, 2s superscript 2, 2p superscript 6, 3x superscript 2, 3p superscript 6, 4s superscript 2. So if you add the superscripts together, they will give you 20 atomic number. The group is equals to 2 and the period is equals to 4, because the s orbital is completely filled. Since the s orbital is completely filled, then it falls within the group 2 element, and the period at which the last orbital there is 4, so it is in the period of 4. So if you are told that you are given something like this, 1x2, 2s superscript 2, 2p superscript 6, 3s superscript 2, 3p superscript 6, 4x superscript 2, 3d superscript 10, 4p superscript 5. You know that 4p superscript 5, 4p superscript 5, meaning that p is almost filled. 3d is not also completely filled. Since the two last elements are not almost filled, so then the one that is close to filled, that is almost filled, will now take up the period of the element. Since the 3D still have 4 elements to fill it up, and it will not go back to 4s2 orbitals, because that one is still far from what they want. Then it has to fall back to group 4, since group 4 element is almost filled with electrons. Yeah. Positions of electronic configuration in periodic table. Then the electronic configuration is the formula that scientists use in producing the periodic table. The electronic configuration consists of columns and rows. The columns of elements in the periodic table are called the group, while the rows in the periodic table are called the period. Then the first elements in group 1 and 2 columns are metals. These metals are in the first group of elements at the left hand side of the periodic table. Then at the middle of the periodic table we have the metalloids. They are neither metals or non-metals. Sometimes they behave as metals, sometimes they behave as non-metals. These are the d orbitals. Then the elements that are in group 3 to 0 are non-metals, which are in the group P, which their the electronic configuration, and they can only contain p orbitals in their outermost shells. Then we have the f orbitals, which are radioactive elements and isotopes, which are formed by radioactivities in their making. Group 1 and 2 makes up the s orbital. The elements in the blocks are the reactive alkaline and alkali earth metals. Group 3 to 7 and 0, from the p orbitals, electrons are added progressively to the p orbitals as we move across the table from group 3 to group 7 and 0. The element in p blocks changes from moderate active metal in group 3 to a very active non-metals in group 7, and finally unreactive noble gas in group 0, which appropriately marks the end of each group. Thus, we see that the position of x and p blocks elements in the periodic table are related to x and p electrons occupying the outermost electron level of the atoms. The transition elements occur between groups 2 and 3 in the periodic table. They form the d block because they contain d elements in addition to s and p electrons. As we progress across the transition series from left to right, the electrons that are added fill up the incomplete inner d orbitals of the atoms of the elements. The electronic configuration of the atom's energy level remains fixed as 1 or 2 s electrons. Here, we see the position of transition elements in the periodic table are related to the presence of d electrons occupying the inner orbital of the atoms. The partially filled d orbitals confer special property on the transition element. The transition elements, which are all metals, are similar among themselves and differ from s block metals. The lactinide and the antinide occur between group 2 and group 3 in the periods in period 6 and 7 respectively. They form the F block because they contain F elements in addition to the S, P, and D electrons. The F electrons are added to the inner orbitals of the atoms. The lactinides and the antinides exhibit very similar properties, which are due to the presence of the F electrons. Clearly, the relationship between electronic configuration and the position of elements in the periodic table are clearly shown that the S can only contain 2 electrons. The D can only contain